We're going to start the morning by hearing about the early epidemiological work that Simon had a key role to play in, and it's amazing how many international meetings one goes to. One sees work of Hammond et al. Up on screen of international conferences, and it's really been seminal epidemiological work. And we're then going to move into other areas, talk about treatment, and we're going to end up with some more sort of pie-in-the-sky sort of stuff, biomarkers, how we're monitoring for MS, and then finally we're going to have a discussion about how we can get to a permanent treatment, a permanent cure of this disease. So thank you very much, everybody, for coming up to this meeting. It's a group of neurologists, of basic scientists, people of all stages of their careers, people who've just submitted their PhD theses, and so we're grateful to everyone to come along. And not one person, actually a few in Melbourne said that they couldn't come, but apart from that, every single person I've asked to speak has given of their time, so I'm incredibly grateful. I'm also incredibly grateful too for the support that we've had from the pharmaceutical companies, which has allowed this meeting to be supported and certainly made it much easier to run. And of course, some of you don't know Simon Hammond, and I've had the privilege of working with Simon since 2004. But just for those who don't know, Simon Hammond is he started off work in the UK and then moved to train in neurology in Australia, in Canberra and then Perth. Recognised by Simon's being awarded the Member of the Order of Australia. I haven't put every single paper that Simon's published, and we're really focusing on MS, but he's actually contributed to a lot of different fields, and many of these papers are very high impact papers. So that's enough of an introduction. So I'd first like to introduce Professor Jim McLeod, who is going to talk about the early epidemiological studies. And part of the theme of today is contrasting work from the early days to where we are now. So I'm very grateful that everyone has joined in with this theme. So, Jim.
I'm going to talk about the early epidemiological studies in Australia. Now, we owe a lot to Jane Frith, who's here. She did a history of MS in Australia and found that the first description of the disease was in this country was in 1985 by this gentleman here, Dr Alfred K. Newman. And he later somehow became the mayor of Wellington in New Zealand, and I'm not sure how these two matters are related, but there it is. So he was one of the first to speak about multiple sclerosis in this country. The first clinical cases were reported also by Dr Alfred Jamieson, who's a very intent-looking man there, and the first clinico-pathological report was by Drs Fruard, Flashman and Oliver Latham in 1915, and they made some very important observations on the neuropathology. Interestingly enough, Oliver Latham I had met many years ago. He was a distant relative of Bernard Huxtable, who many of you know, and he used to pop into Sydney University to see Bernard Huxtable because he was a distant cousin, and he used to take him out for a tip of tiffin, he used to say. Rather an eccentric man, but he was a very good pathologist. And he worked in the Anderson Stewart Old Medical School building in anatomy for many years, up to 1953, and was a very valued mentor, and I met him at that time. Now, the first Australian neurologist to focus clinical research on MS was John Sutherland. He'd established a fine reputation for research through his epidemiological studies of MS in northern Scotland before emigrating to Australia, where he initiated investigations with collaborators John Tyrer, Mervyn Eadie, Casey and Kurland that showed that the prevalence of MS was significantly lower in Queensland than in UK. He was a delightful man and did some marvellous work on the early studies of the epidemiology of MS in this country. Another person who made big contributions was Michael McCall from Western Australia, and he and his co-workers undertook a rigorous epidemiological study of MS in 3 Australian cities, Perth, Newcastle and Hobart, and these showed a prevalence gradient increasing with the distance from the equator. This finding supported similar studies in Northern Hemisphere. Australia provided a unique opportunity to study the relationships of the frequency of the disease to latitude, extending over 30 degrees in a predominantly Caucasian population with a reasonably uniform ethnic mix and comparable socio-economic conditions in all the states. So it was a very fertile area for a microbiologist, as Michael McCall was. He was a proper microbiologist. Certainly I'm not. So how did we set up this epidemiological study of MS? In those days, the multiple sclerosis societies were separate entities in each state. They all had different minds about what should be done, and we were able to persuade them that it was worthwhile doing an epidemiological study of the whole of Australia. Unfortunately, Victoria, for various reasons, was unable to participate in the studies, but every other state was very great in helping. Dr. John Kurtzky, a famous MS epidemiologist, was invited by the MS Society to come over and advise about the scope and conduct of the research. It was essential to have somebody who was going to be there full-time, going through all the material, because we had to check out what happened in other states and make sure we had a uniform system of analysing the studies. And Simon was an excellent choice. By virtue of his friendly nature, his training in neurology and his intelligence and ability to communicate and work with others, because there's a lot of interstate rivalry going on, he was able to gather the important clinical information about the individual patients in all the states. And without Simon, we would never have been able to complete the survey. So it's a great pleasure to have worked with you, Simon, over the years. Now, just quickly, some of the studies that were done. Oh dear. This shows Australia with the various latitudes and the prevalence in each of the states and the 3 cities. And you can see quite easily that there's an increase in prevalence as you go from north to south. This shows later putting together of the prevalence of MS, and it shows the prevalence in the states and also the prevalence in the three major cities that we were studying at that time. So there was a virtual straight line relationship between latitude and prevalence, as you can see by looking at that graph on the right and also on the map of Australia. From these numerous studies, in which there was a lot of work done, we found a significant increase in incidence, prevalence and mortality the further you went south in the country, which was attributable to unidentified environmental factors that include the hours of exposure to sunlight, vitamin D levels possibly, or possible virus and other infections. Genetic factors in this north-south relationship didn't appear to play a significant part. It was more the climate and the latitude. The clinical features are similar in all the surveyed areas of Australia, with the exception of Queensland, where there was a greater tendency for males to develop a progressive course and have greater disability, possibly the result of migration of MS patients from southern areas to the warmer climate of Queensland. We don't know. No full-blooded Indigenous Australians with MS have been detected in any of the surveys, to my knowledge. Migrants from the UK and Ireland have a reduced risk of developing MS if they have an onset after migration than the risk in their country of origin, but a higher risk than native-born Australians. The frequency of the migrant group shows a relationship to latitude in Australia, and these findings support the influence of environmental factors in the disease. So this really just says that the age risk of developing multiple sclerosis is not as marked as it had been in earlier studies. It used to be said that if a migrant came out before 15, they had the same prevalence of multiple sclerosis as if they came out after. But in our study, putting it all together, we didn't find that was the case in most instances. The conclusion was that MS is greater in people of or higher educational level and socio-economic status. Why, we're not sure. There's a greater level of divorce, separation, and a lower rate of participation in the workforce in people with MS. And there's a worse prognosis associated with older age of onset, progressive disease, onset symptoms are multiple, pyramidal or cerebellar, and there's a short interval between onset and first relapse. So there are a lot of factors that influence the development of the symptoms of the disease. So that was the socio-economic factors that we were talking about in the last slide. Another conclusion was that there's been a significant increase in the incidence and prevalence of the disease over a period of 35 years, from 1961 to 1966, which is quite a long period of time to be doing repeated prevalence studies. There's been an increase in the age of onset and female preponderance over the same time period. None of these things are properly explained at present. Median survival from the onset is 42 years, which represents a 10% reduction in lifespan compared with the general Australian population. The expected time to reach a disability of DSS-6, which is requiring walking aids, is 27 years. So there's quite a long period of time that the sufferers of MS have to put up with their disease. That's why it's so important that there are new studies showing much better and effective treatments than we had before. So, to round it off, these epidemiological studies of MS performed over a period of 25 years are the most extensive that have been conducted in the Southern Hemisphere and have contributed substantially to knowledge of the disease. The same methodology, diagnostic criteria and prevalence days were used in all the states, thus avoiding the problems associated with comparative studies in the Northern Hemisphere. Thank you.
Anybody have any questions? Dr. Margaret.
They correlate with those in the American continent?
Similar findings, yes. Different numbers, but similar findings. We did John Kurtzky took a great interest in our study, and unfortunately the poor man died a year ago, and we were still collaborating at that time. There's one more paper to go.
Professor Byrne, one last question.
Hi. The latitude gradient effect seems to be disappearing. What do you attribute that to?
I don't really know. Might be movement of the populations from one end to the other, so that looking at different base, I'm just not sure.
Thank you very much, Jim.
Thank you, Simon.
So yeah, revisiting the Australian MS population, the 1981 study, we'll start with some other 1961 data. Atchison contributed an important study. He looked at the mortality data in the 6 states between 1950 and 1959, and he found that there was a close relationship with latitude for MS deaths, with the exception of Queensland, where there was a higher than expected rate, but not for motor neurone disease. So clearly these two diseases were different in that respect. Then in 1963, he published a study in which he indicated and found that the MS mortality rates in the UK-born migrants were slightly less than the Australian-born population and considerably lower in both groups than in the UK. And he cited possible reasons. One was pre-selection of the UK migrants to exclude MS sufferers, underdiagnosis of MS in migrant and non-migrant populations, and perhaps a migration effect, reducing disease incidence and fatality. Then there were the 1961 point prevalence studies that Jim has spoken about, all conducted along the same lines using the Allison and Miller criteria of 1954, with the prevalence day being the 30th of June 61, apart from Queensland, which it had to be different. So they were done in Queensland, South Australia, the 3-city study that Jim has talked about in Perth, Newcastle and Hobart, and also in Western Australia. So yes, we've seen this map already. I mean, the maps have basically been recircled and recycled many, many times. But we can see here that Queensland tropical 6.8 down to Hobart 31.9. There was clearly a significant drift to increase prevalence with increasing south latitude. The only dissenting voice at that time was South Australia, which seemed to have a higher rate than was expected. Obviously, most of the South Australians live in this small area here, but that's still considerably higher than Newcastle. So if you standardise the prevalence to get rid of any sort of anomalies in terms of the construct of the denominator populations, and we didn't have age specific sort of data for some of the areas, but it really made very little difference. We can still see that there was a considerable increase in latitude, increase in prevalence with increasing south latitude. So Mike McCall sort of looked at the anomaly in South Australia at the time, and he felt that it was probably overdiagnosis of MS in that survey that caused the anomaly. And he then looked at the prevalence figure, compared it with the age-adjusted mortality rate for that state, and found that they were considerably at variance, whereas in the 3-city study, the two factors were obviously very much in accordance. So the main conclusions from 1961 was the frequency of MS within Australia has increased with increasing south latitude. The frequency of MS in the UK-born population was similar to the Australian-born population and considerably less than that in the UK at the time, possibly due to migrant pre-selection. And the majority of MS patients in Australia, born in Australia, had never travelled out of the country, and that basically contradicted the early belief about the disease in Australia, that basically it was acquired by overseas travel. So the other conclusions, MS in Australia appeared to be a similar disease to that in the Northern Hemisphere. The female preponderance at that stage was somewhere between 1.5 to 2.3 to 1. The clinical features were similar. The familial occurrence was also very similar, 4 to 10% in each of the survey areas. And as Jim said, no full-blood aboriginals with MS found in any of the survey areas at that time. So in 1981, as Jim said, we basically set out to repeat a lot of these studies and to look at other things. We did point prevalence studies. This time we used the Rosedale criteria. The prevalence day was the 30th of June 1981, which is a national census day. We looked at Queensland, the 3 cities, again, Western Australia, New South Wales and South Australia. We looked at the clinical profile, as Jim pointed out, and compared medium and high frequency zones. We looked at the contribution of mortality statistics to the study of MS in Australia, as Atchison had done earlier. We looked to see why the MS frequency increased with latitude in Australia. What were the reasons for that? And in combination with David Miller, we combined our work with the New Zealand studies of that time, and again asked the question, are the determinants of our latitude gradient genetic or environmental? We looked at socioeconomic factors, as Jim has said. We looked at prognostic factors, and we looked at migration data. This seemed to be an important thing to look at. More recently, with John Kurtzky's collaboration, as Jim McLeod said, we were asked to review certain aspects of our conclusions, and these 3 papers were published. The first of all re-examined the risk of MS by aged immigration. The second looked at the characteristics of the early migrants coming before 1947 in comparison to later migrants. And the third looked at the risk of MS in UKI migrants, that's United Kingdom and Ireland, immigrants, and Australian born in Hobart, Tasmania, which was principally authored by Michael Barnett. So first of all, a latitude story. Here we are in 1981 looking at crude prevalence. And again, now we see a gradient between 11.1 and 74.2, which is a 7-fold increase down the eastern seaboard of Australia at that time. And this time, everywhere really fell into place, including South Australia. If you standardise the prevalence, as I say, to get rid of any anomalies in terms of sort of patient, at least denominator population construct, really there's no real difference. It's still a 7-fold increase down that eastern seaboard, with everywhere basically being in between the 2 extremes. One of the concerns that we had, I guess, was that the population sizes that we looked at were considerably different, and that does make a difference. Obviously, the smaller the population size, the more complete the ascertainment, and therefore you could skew figures, because look at this, below the tropic in Queensland, we looked at a population of 1.9 million versus 390,000 in Newcastle versus the smaller 188 odd thousand in Hobart. So that's a potential sort of confounding factor. However, I'll just go back to that we did see, obviously, despite that, again, this very, very strong relationship with latitude, and we looked at that in terms of rate ratios. If we just looked at the Australian-born population, we saw the same thing. Again, a very strong relationship with latitude. When we combined the data, as I said earlier, with that coming out of New Zealand, again, we found that it all sort of fell into place pretty much. There was a little bit of a wobble around here, but if you look at the confidence intervals, they all cross over. But yes, we go from tropical Queensland down to Otago, Southland, in the south part of the South Island, where they had a prevalence rate of around about 82. So one of the ways in which we wanted to sort of to corroborate our data was to look at the mortality rates, because that obviously was independent sort of data from ours, and we can see this is expressed as standardized mortality per 100,000 person years. We can see again that there's a strong relationship between with latitude, with increasing south latitude in terms of these mortality rates. And this data also confirmed that Victoria, where we were not able to get any prevalence data, was also in the mix with figures that were sort of intermediate down that eastern coast of Australia. So that was important confirmatory evidence for us. So yes, this basically, again, just compares the rate ratios in terms of increasing south latitude between mortality and prevalence, and really they coincide very well. So that we were not sort of, therefore, I think, finding an anomalous sort of study simply because we had such differing populations to look at. So yes, having found that, we decided to try and sort of ascertain whether or not this was an environmental situation or whether it was genetic. Clearly overseas, in the USA, where we've had very much the same sort of latitude situation, and also in the UK, it was kind of thought that that there was a considerable genetic influence, which was based around the Scots. At the time, the HLA sort of DR2 antigen, which was the one most closely associated with MS, was known to be much more frequent in the Scottish population. And so it did seem to bias the situation in the UK. And it was thought that a lot of the people who migrated to the USA from Scandinavia and Scotland basically took their genetic high risk with them. And that's what was skewing the latitude story in those countries. So one of the ways in which Skegg, who's from New Zealand, basically looked at to see whether or not he could sort of ascertain whether or not there was Scottish ancestry that was increasing with increasing south latitude, he looked at the Mooks and Macks in the telephone books of New Zealand, and found that there actually was a correlation, and that the people in Otago Southland were more inclined to have Mook and Mack sort of surnames than people, say, in Waikato. So we did the same thing. And we found, in fact, that the reverse was true. There were actually fewer Mooks and Macks in Hobart than there were in Queensland. So we found no relationship there at all. Obviously, it's a very crude index. But we did look at the data from the ABS at the time. So this looks at United Kingdom and Ireland migrants in 1981, divided up by Scotland, England, Wales, and Ireland. And again, we can see that there were actually more Scots further north than further south in a general sense. So that clearly, again, suggested that we were not looking at a bias by having Scots basically sort of predominant in the southern areas. It seems in Australia they were seeking sunshine and light rather than the mists of Scotland. So we then looked at the HLA DR2 antigen frequencies. We were able to get data in New South Wales, South Australia, and Hobart Statistical District. We were calculated to sort of meet what we call mean south latitude. In other words, we looked at the distribution of the population, and we sort of calculated where the mean south latitude was. And we can see that basically HLA DR2 positivity was very important in terms of the MS patients in these three areas, but there didn't seem to be any sort of huge difference in that. In fact, really no difference at all in terms of almost 10 degrees of south latitude. The controls, the same basically, and this was important data. Obviously, we see about 30% of the population have HLA DR2, so rather considerably less than the MS population, but again, not varying by latitude. So there was clearly, no obvious evidence that we were looking at genetic influences. Obviously important in terms of deciding the risk of developing MS, but not important in the latitude story. So yeah, so that's really was the conclusion. So as Jim said, our data suggested that there was environmental factors were extremely important in determining MS risk, certainly in 1981. So the change in prevalence story between 61 and 81. This study basically sort of shows that in all areas the risk has gone up, except in South Australia. As I say, there was an anomaly there where there was thought to have been over-ascertainment in the early studies, and that did seem to have fallen, but everywhere else it increased substantially between the two survey times. So what can change MS prevalence over time? Well, patient survival obviously is important. The case ascertainment is important. The study-restudy effect. Improved diagnosis of the less severe forms of the disease, availability of modern diagnostic techniques, even though we didn't use those as part of our assessment. Of course, a change in incidence and a change in the age structure of the population to favour older age groups, which we obviated by age standardising the data. And finally, differential migration of patients or populations at higher risk of developing MS compared with the general population. So looking at patient survival, we can see here that the mortality rates between 1950 and 59 and 1971 and 80 dropped substantially in all areas, rather with the exception of Western Australia, where we thought probably the fact that there was no MS society in Perth and Western Australia before 1960 may have had an influence in that area, and we have some corroborating data for that. If you look at age-specific MS prevalence for all persons, the lower graphs in each one are 1961, the higher graphs are 1981. What the important point here really is that the numbers of patients or age-specific prevalence rates for people in their 7th decade and older was considerably higher in all of those 3 city areas. And so people were surviving a lot longer, and that's really the bottom line there. And if we looked at Western Australia, despite the anomaly in the official mortality data, again, we can see the same thing happening there. Very, very many more people who lived into that decade and beyond. So that clearly survival was improved survival was a very important reason for increase in prevalence in our survey. Case ascertainment, just going over this, basically the study-restudy effect, which you can sort of ascertain by looking at the number of sources for each individual case. That had a positive influence in Newcastle and in Hobart, a negative influence in Perth and Western Australia and South Australia, and we didn't have data for that in Queensland. Recognition of less disabled patients was certainly important, positive influence in Perth, Western Australia, Newcastle, Hobart, but no data on that basis for Queensland and South Australia. Laboratory investigations determined by the mean duration of disease data, we would have thought that would have gone down if there had been an influence of that, but in fact exactly the opposite occurred. The mean duration of disease data actually increased, so there was no influence from that. The migration factor, yes, there was an overrepresentation of MS incident cases in the overseas-born populations of Queensland, Perth, WA, Hobart, so that certainly made a difference. It was a neutral factor in Newcastle, and it was a negative factor in South Australia, so a bit variable. The migration factor, again, we looked at whether or not the Australian-born population had spent a lot of time travelling to high-risk areas. We didn't have a lot of data in 1961, but we can see that really it was only tiny proportions of people who'd gone overseas to high-risk areas for MS before they developed MS in this country. So we didn't really think that that really had any influence, and that, again, I think concurred with the 61 data. So incidence clearly went up in Newcastle, clearly went up in Hobart. We think probably to an extent that may have related to improved case ascertainment in Newcastle, and in Hobart to the migration factor. Incidence was a neutral thing in Perth and Western Australia. It was negative in South Australia, and we didn't have any data on the 61 incidence in Queensland. So at that stage, we didn't really feel that true increase in incidence was necessarily that important. But I think the improvement in survival was the thing that we felt that was probably the major influence as far as the increasing prevalence. So now turning to clinical aspects, basically the female-male ratio then, obviously it's changed a lot over the years, but it was around about 2.4 to 1 in taken overall, and that was pretty much the same as we were seeing sort of elsewhere in the world at that time. Family history of MS, either looking at it in terms of patients or families. Again, interestingly, pretty similar in most of the areas, except in Hobart, where in fact there seemed to be a higher rate of family positivity, which was around about the 16 to 17% mark, but everywhere else it was around about sort of 5 to 7. But yes, it was certainly something we saw in each area. Again, as Jim said, there were no cases amongst full-blood Aboriginal Torres Strait Islanders in any of the survey areas, but really working out how many we would have expected in terms of the population at the time was only 10. So, you could have easily missed that, I guess, by a chance. But interestingly enough, where the HLA-DR2 typing data on Aboriginals suggested that they were pretty much the same as the non-Aboriginals, and so you would have thought perhaps that their risk of developing it on the basis of that at least was the same as the European population, but there you go. So yes, comparing high risk or higher risk 3 cities versus Queensland in terms of disease behaviour, looking at their clinical profiles. A lot of similarities really in terms of diagnostic categories. Definites were about sort of 70-odd%. Mean age at onset around about the 32 mark. Median disease duration by 1981 was much the same, about 12 years. The disability cohorts were pretty much the same in overall terms, looking at an EDSS of 0 to 3, 50% in Queensland, 56% in the 3 cities, and 7 plus, 27% in Queensland and 23% in the 3 cities. But there were some important differences, as Jim pointed out. If we look at basically exacerbating remitting, progressive from onset, exacerbating remitting, becoming progressive, the figures for the females in both areas, the 3 cities, the higher risk 3 and the medium risk Queensland, were very similar, but not so for the males. There were certainly fewer exacerbating remitting males, more progressive from onsets, and particularly more exacerbating remitting becoming progressives amongst the males in Queensland. So really quite an interesting sort of difference. And it has been shown in other areas basically that hotter areas perhaps do have more aggressive disease. If we look at the median Kurtzky disability status score in 1981, males 5.4 versus 2.9 in the 3 cities, 3.3 and 3.1 for the females. So they were very similar, but the males were clearly much more severely affected in Queensland. So in overall terms, the clinical profiles were similar, but those differences were that more males followed a progressive disease course in Queensland than the 3 cities, mostly because more males went from exacerbating remitting to progressive, and accordingly that meant that the Queensland males had greater disability than the 3 city males. We wondered whether the difference in that was due to acceleration of the disease process by repeated heat exposure, and that has been, or was found at the time in certain studies in the USA. It's only, of course, conjecture. The socioeconomic factors, Jim sort of covered that, so I won't spend too much time, but we had about 2,300 MS patients that were around 20 or more in 1981, and we found a significantly higher frequency of MS in those who left school at an older age and achieved a higher educational level in both men and women. And that was something that had been found by John Kurtzky's group in the USA in a study of US veterans. Not surprisingly, when we compared marital and employment status according to disability, defining low disability as between 0 and 3 and high disability as 7 to 9, we found that if we looked at the age-adjusted estimated risk ratio of divorce and separation, 4 times more likely to be divorced as a male if you were in the high group versus the low, and 2 times if you're in the high group for the females. Employment, males were about 50% employed, females about 27% employed in 1981. And the risk of, not surprisingly, the risk of unemployment was massively higher in those in the high EDSS group, 18 sort of times more common to be unemployed in the males and 25 times more likely to be unemployed in the females. So that's really no great surprise, but obviously of considerable impact in terms of socio planning for patients with disability. The prognostic factors, Jim's covered that really. We had 2,890 MS patients to look at in that respect, which included actually data from Victoria. And as he said, the factors associated with the worst prognosis were older age at onset, a progressive disease course, onset symptoms that there were multiple, pyramidal or cerebellar, and a short interval between the onset and the first relapse. And the converse was true, therefore, with what was associated with the benign disease. I was always a bit surprised that brainstem sort of onsets, carried a relatively low risk of becoming disabled, because that did seem to be sort of inherently peculiar to me, but that was certainly what the data suggested. So going on to migration, the early migration studies from South Africa, Hawaii, Israel suggested that the risk of developing MS is largely determined by the age of 15. So as Jim said, if you went from a high risk to a low risk sort of area, basically before the age of 15, you assumed the lower risk of the area to which you had gone. But some studies in America, Roger Details, basically in 1972, 1978, published data that suggested that the age range of risk of MS acquisition could extend well beyond 15. And the cluster of cases in the Faroe Islands that was studied by Kurtzky and Hardestead and Fishman also suggested that same thing. So our study populations were migrants from the UKI, who were 42% of the total migrants in the study area. In each area, 80% of those migrants were from England. At the time, the concurrent MS prevalence rates was between 90 and 100,000. 90 and 100 per 100,000. And interestingly enough, 70% of those had migrated at or after the age of 15, and only 30% therefore before the age of 15. We confined our analysis to UKI migrants with onset of MS after migration, obviously. And we were constrained by the available census data at that time to looking at patients between the ages of 20 and 49 in 1981. So we did 3 analyses. First of all, we studied MS prevalence and latitude in Australian-born and UKI-born populations. That included the Hobart data. We then looked at analysis of MS prevalence in UKI-born patients according to migration before and after the ages of 15. That excluded the Hobart data because Hobart was clearly a high-risk area, and moving from one high-risk zone to another is relatively uninteresting in terms of the effect of migration. And then we analysed the effect of age of migration to and the duration of residence in Australia on the risk of acquiring MS in a case control study where the case controls came from, obviously, from ABS census data. Probably very difficult to see, but obviously we've already seen that there was a statistically significant relationship between increasing south latitude and prevalence in the Australian-born. If we look at the UKI-born, there was, in fact, in that study, again, a significant relationship with latitude, but it was very much swayed, in fact, almost totally swayed by the Hobart findings, which was really only very small numbers of patients, 18. But when we did a comparison between the two latitude gradients, statistically they were the same. But really, when you look at these figures here, the prevalence ratios in the mainland Australia, they're pretty similar. And this is what we found in the later study as well. This study, basically, this is looking at age of migration amongst migrants to Australia, aged 20 to 49, as I said. Basically, we looked at the prevalence if you migrated before 15 and migrated after 15, and we found actually that there was a negative relationship. In fact, you had a lower prevalence migrating over the age of 15 when you were supposed to take your high risk with you. And even when we sort of isolated a group between 30 and 49 years of age in 1981 basically to reduce the bias towards finding a sort of higher prevalence rate in those migrating before the age of 15, we again find the same thing. There was kind of like a negative relationship. And in terms of age of migration, prevalence of ratio in our case control study, we didn't really find that there was anything basically in that to suggest that that this before 15 and after 15 relationship applied in Australia. Similarly, duration of residence seemed to have really no effect, and when we studied it in these duration of residence quartiles. So really we concluded at that time that the risk of developing MS was spanning a much wider age range than childhood and early adult life in Australia. As I said, we were asked then to reanalyse that by John Kurtzky. I think he was unhappy about the conclusions that we reached to an extent, although he agreed with the data analysis at the time. So we did a different analysis this time, basically. So we omitted Hobart from all analyses. As I said, it's really not very interesting to study high risk to high risk. It doesn't really contribute. This time we had a denominator population at risk of developing MS by age at immigration, that's AAI, calculated again from the ABS census tables of the length of residence in Australia by the age of 0 to 79 in 1981 for UKI migrants migrating between 1947 and 1981. The numerator population was the same, but so we were limited to the subset of 258 UKI origin MS patients with onset after immigration, arriving in 1947 and afterwards, also aged 0 to 79 in 1981. And we called them Group 1. And we calculated, using this technique, absolute risk ratios per 100,000 for MS at each age at immigration. And what we found was this. Basically, age-adjusted prevalence to the 1960 US population. That was John Kurtzky wanted us to do that for some reason. By the state for the UK, by state for the UKI immigrants in Queensland, and this MSL is mean south latitude. It was 24 in Queensland for UKI, 27 in Western Australia, 32 in New South Wales, and 21 in South Australia. And that was not a significant gradient. And that's, as I say, what we sort of kind of found if you just look at the mainland states in the initial Brain paper. For the Australian-born, though, it was 18 in Queensland, 25 in Western Australia, 35 in New South Wales, 26 in South Australia. And that was a significant gradient, as indeed all of our other studies had shown. If we looked at by age at immigration, we had 56 patients between the ages of 0 and 14 at migration. So our absolute risk ratio was 22 for them. If we looked at those who migrated between the ages of 15 and 39, the absolute risk ratio was 54. And looking at those confidence intervals, that's clearly a statistically significant difference this time. So that it did seem to matter what age you were to an extent by migration, analysing in this way. So why the different result to the previous analysis? Well, it was a different study group. We excluded the UKI MS patients with entry before 1947, there were 44 of them, called Group 2. They were included in the initial analysis, but not in this subsequent analysis. And we think probably the denominator population was more appropriate on this occasion. And the denominator populations are obviously vital in this sort of kind of study. The other rather embarrassing thing was that there was an inadvertent double counting of 21 cases in the original study in New South Wales, most of whom had young age at immigration, and that, of course, would have swayed the finding in favour of there being no difference between less than 15 or more than 15 at the time of immigration. But it still doesn't get away from the fact that all this data shows that UKI MS prevalence rates in 1981 were much lower in mainland Australia than in the concurrent studies in the UKI. And that was, if you looked at the mortality data, that was concordant with our finding. So what are the possible contributors to that? Well, obviously, exclusion of patients with onset before migration in the analysis, that actually accounted for about 25% of the migrants. Did have onset before migration. That would have boosted it up by 25%. Obviously, a decreased likelihood of migration in patients with established MS. Differential migration of population with lower educational level and socioeconomic status, obviously at a lower risk of developing MS. Obviously, in the migration after World War II, probably those people with higher educational levels and higher socioeconomic status stayed in the UK, and those who perhaps in a lower situation looking for work would have been those who migrated here. And I think more importantly, though, modification of MS disease risk by factors in the mainland Australian environment. So just briefly, time's pretty much up, the other two papers, the characteristics of the pre-1947 migrants in comparison to the later migrants. So Group 1, those are the ones who immigrated before 1947 compared to Group 2 with immigration after 1947. If we looked at group 1, there were 15 of them who were similar to group 2 in terms of age at immigration, age at onset, and the time interval between age at immigration and age at onset. But there were 29 of the group 1 who were very, very different to group 2. Age at immigration was a mean of 4 years as opposed to 23 years. The age at onset was 40 years, rather older than group 2. And the mean interval between immigration and onset was 35 years versus 10 years. So something very different about them. And all onsets in this group 1B occurred after 1947. We know that immigrants from high-risk MS countries, including the UKI, were modest in number before 1947, but a huge number, 770,000, came between 1947 and 1981. And Kurtzky, I think, is obviously keen to think that that you can transport risk or transmit risk, by sort of population movement. And he felt, and I think what we concluded as a group, that Group 1B, this rather different group, most probably acquired their MS in Australia, and more likely from interaction with those immigrants than with the Australian-born population. So, in other words, the whole question, rather controversial question of transmissibility, came up with this particular study. So, and finally, looking at the risk of MS in the UKI immigrants and Australian-born in Hobart and Tasmania, which Michael Barnett was the principal author of, we looked at, again, just reanalyzing it, and we age adjusted it to the 1960 US population. 20 patients had a prevalence rate of 133 per 100,000. The mean interval between immigration and onset in the patients migrating at under 15 years was 22 years. That's only 9 patients, but it was 6 years, only 6 years in patients migrating after 15 or at or after 15 years. There are 11 patients, so very small numbers, but did rather suggest that the acquisition of MS in Australia was in Australia in this former group migrating before 15 years. The Australian-born age-adjusted prevalence with 99 patients in that study was 73 per 100,000, so rather less obviously than the UKI. If we looked at MS incidence in Australian-born MS population who were alive, and I emphasise that in 1981, it rose from 1.6 per 100,000 between 41 and 65 to 3.5 between 66 and 81. Obviously, quite a number of the MS incident cases in that early cohort may well have died by 1981, and that would, of course, have brought that figure down. So was that a true increase in incidence? Yeah, probably, but can't be absolutely certain about that. But again, the immigrants from high-risk MS countries, including the AKI, were modest in number before 47, but lots of them came after 47. And the postulate as a result of this particular study was that MS was possibly transmitted into the Hobart Australian-born population by intermingling with a higher-risk MS immigrant population. In other words, this transmissibility situation was possibly applying there. So these were the 3 later studies. And with that, I'll end. Thank you.
Thank you very much, Simon.
Pleasure.
Anybody like to ask
Burning questions.
burning question?
Chuck on.
So, clearly the accuracy of diagnosis is going to be very important in these sorts of studies. These days with the expansion of subgroups of MS, mild NMR, etc., how do you think it's going to influence our data? I mean, this is based on epidemiological studies up until recently.
I think theoretically it's going to have a profound influence, I think, really. I mean, as I say, we had no MRI data. We deliberately avoided CSF data and everything there because we really wanted to sort of try and be as uniform in our ascertainment as we possibly could across the board. But yeah, look, I mean, I think it clearly these days, if you did a study like this, you'd be mad not to sort of to have all that data. I'm sure it would make a big difference. I mean, obviously it's going to find a lot of earlier onset cases. It's going to increase prevalence because, you know, diagnosis is going to be that much easier and more certain, as it obviously is these days. So yeah, I think those sort of kind of factors are going to make any comparative study that one does very much harder. Actually, I don't know. I mean, Michael, you were involved in the Newcastle sort of follow-up studies after 1981. I can't remember. Did you actually use MRI data and so forth? You stuck purely.
But, I think Jeanette Lakener-Scott did in her more recent
Right.
Newcastle analysis.
Yeah.
Which we're just going to hear about next.
Okay. Yeah, but I think the bottom line, yes, I think these things are very important, and we didn't have them then. We do now. We must use them. Yeah.
What I will say, though, is that your clinical notes were the most meticulous, beautifully written clinical notes in MS that I've ever seen. And Jim McLeod, we still store them at the Brain and Mind Centre. And if those patients didn't have MS, then I don't think anyone did, because they were wonderful.
Could you read them?
I could.
My handwriting was terrible. Well, thank you for that. Thanks.
Organisers for putting me amongst such a prestigious group of speakers today. And as indicated, I've been left with this topic, which I'm not going to try and answer definitively, and just put some ideas out there and we can have some discussion more about if MS is increasing in prevalence, why is this happening? Okay, so we've definitely seen globally that there's been a shift in the prevalence and incidence of MS. So historically seeing that global latitudinal effect, where the further you were away from the equator, the higher the incidence and prevalence of MS. And this is taken from the MS Atlas and is actually expressing the 2013 distribution of MS cases. And I think it's probably due to be updated because we're seeing even more cases in areas that historically out of North America and Europe, cases are on the increase. So I'll be talking a little bit about those later on, not just restricting our discussions today to Australia, but basically looking at what's happening in the Middle East, in countries like Latin America, and in Australia as well. So we've seen this so many times today, but just to remind you of the gradient that was reported in 1981 with a latitudinal effect happening in Australia. And as both of my previous speakers have indicated, the latitudinal effect we see from tropical Queensland down to Hobart. Now I feel like I've had the baton passed through history of the very extensive data set that's been collected in Newcastle. So going back to the early 1960s studies and to the most recent study that I've worked with Professor Lakener-Scott in Newcastle, we've restricted just into the same demographic region, which is an inner urban region of Newcastle. We now have 50 years follow-up data of epidemiological evaluation of multiple sclerosis. So just to give you a bit of a preview, I'm sure most of you know where Newcastle is, but we're basically an east coast city, 32 degrees south, 151.7 degrees east. We're bordered by the Pacific Ocean on one side and a large body of water, Lake Macquarie, on the western side. So all of the studies that have been conducted, and I guess this is the beauty of having sort of the bubble that is Newcastle, that all of the previous epidemiological studies have been conducted within the Newcastle Council region. Now this, as I said, is predominantly an inner city urban area, and really the borders and the region that's covered and has been analysed over the last 50 years has been restricted to that one area. So it's a really nice population to look at consistent changes if we're talking about changes in MS within that defined population. In terms of ethnicity, and we've heard a lot just then about migration into and out of Newcastle, again, we've remained pretty consistent and that we are predominantly out of the non-Australian born residents. The largest group has been from the UK. We have had the influx in the last 15 to 20 years of more Asian populations, but again, this has remained pretty consistent and remains at around 5% of that population. So we conducted a prevalence and incidence study of multiple sclerosis in the Newcastle region in 2011, and again, this was aligned with the national ABS census date in August of 2011. And having access to the data from 1961 means that we could look at trends by standardising to the 2011 age distribution, the prevalence and incidence rates changes over these 50 years. So if we're looking at the census population in total, we can see there has been a slight increase in the numbers living in the area, but as I mentioned, in terms of ethnicity, it's remained pretty consistent. Our prevalence estimates, as I said, have been standardised to the census population, to the 2011 population, and we can see that compared to 1961, a dramatic, almost six-fold increase in the numbers of MS cases occurring across Newcastle. And interesting, if we go back and look at Michael Barnett's study done in 1996, we've had a two-fold increase in prevalence in multiple sclerosis in this city, which is very interesting. Looking over at the last column, looking at our sex ratio, so female to male cases of MS within this region has tripled. So a threefold increased risk of MS occurring in women compared to 1961. So we've gone from a female to male ratio of 1.1 up to now 3.1. Now, I thought it'd be interesting to sort of juxtapose this against what's been done in the most recent epidemiological evaluation in Hobart, conducted by Steve Simpson and Bruce Taylor's group. It wasn't a one-to-one, year-to-year comparison, but gives you a rough idea of how the trends have changed. So yes, looking back in the 1960s and 1980s, we do see, if we're comparing the prevalence columns, a definite gradient difference between the two cities. But I think what is quite interesting is if we compare the 2009 figures from prevalence rates in Hobart compared to Newcastle, we actually are now exceeding the numbers seen in Hobart. So that's really interesting as well. So perhaps this gradient effect and latitude effect we've been hearing about is, as someone has alluded to before, now not quite as obvious in Australia. And we'll talk about some of the issues why that could be the case. We've heard a bit too today about mortality rate, and just looking again at Steve Simpson's data in the last column on the right, we know that global mortality rates, with an improvement in healthcare globally, mortality rates have declined. And this is also impacting on the mortality rates we see in MS. So mortality rates have been reduced from 1961 in Hobart from 2.4. Now, in 2001, the most recent data is at a level of 1. So definitely this improvement in the mortality status of MS patients would be contributing to that pool of prevalence that we see. Now, graphically here you can see the prevalence change, and it's quite alarming, and I think really hits you when you look at this graph, to show that the difference in the 2011 age distribution compared to that seen in previous years. So clearly from this graph, that huge hike in numbers that we're seeing, and the peak prevalence occurring in people between 30 and 40 years. I think what's interesting, and this will be alluded to, is that there's an overall shift upward in the graph in that we are seeing also a distribution of younger cases of MS as well. Now, why is this happening? And we alluded to the fact that mortality overall in our populations is improving, but mortality in MS is probably improving because we now have a far better therapeutic strategy for patients. And this plot has a lot of information on it, but we've basically gone from the 1800s through to current times for defining the disease, putting immunomodulatory drugs in place that are reducing relapse rates, to now introducing concepts like NEDA, no evidence of disease activity, which are interacting not just with the disability status of the patient, but also looking at their cognitive and other sort of psychosocial symptomologies as well in terms of evaluating the efficacy of therapeutic strategies. So we're getting a much better therapeutic profile that is improving our status of patients and obviously then improving the survivability of our patients. I thought it was interesting too, in reflection of this, what's happening in terms of the actual disease itself. How are these therapeutic approaches potentially impacting on progression rates in the disease? So this is just comparing two studies. Obviously, we're looking at two different, and there may be regional variations because we're comparing the Lyon French database by Confavreau's group in 2000. And he showed that the time to reach EDSS milestone of 4 took in his population about 11 years, and to reach milestone of 6, 23 years. Now, in a study that we did utilising the MS-based cohort, which many of you I know are involved with, this is a global data set, and I now think has in excess of 50,000 clinical outcome cases. Here we ascertained data derived from nearly 19,000 subjects globally, and again we were interested in this particular paper of looking at changes between men and women in their rate of progression, but if we look at the group overall, we see that the time to reach EDSS in 2011, when the data was captured, took 17 years, 6 years longer than previously reported, and also time to reach EDSS was about 35 years. So we've definitely had a slowing of the rate of progression of the disease as well. So prevalence is being emptied into the bucket of with incidence adding to it. I think incidence is a major player here of why we could potentially be seeing increase in prevalence rates in MS. So this is looking at the incidence data of our 2011 cohort, and we see that our incidence rates, comparing back to 1971, looking at the decadal data up to between 2001 to 2011, we've seen a threefold increase in incidence rates in MS in Newcastle. And again, the female to male ratio is increasing in the incidence cohort from 1 to 3.1. So 3 times greater chance of females being diagnosed with MS compared to males. So I guess, sorry, going the wrong way. And again, this is highlighted if we look at this graphically, and again, age standardising to the 2011 population so that we can compare between these 3 different decade data. We're seeing that the peak incidence is occurring around age of 40. But again, as I mentioned before, I think it's interesting to look at this left part of the panel where we're getting a shift to the left. So that there's evidence here that we are actually seeing more younger women being diagnosed with multiple sclerosis. So to summarise all of our data from the 2011 study, we see that prevalence in Newcastle Council District, which is the same region that's been looked at since the 1960s, so after 50 years we've seen a 6-fold increase in the prevalence of multiple sclerosis. Now, compared to the last survey conducted in 1996, this is a 2-fold increase, and it seems that the prevalence seems to be being contributed to by an increase in incidence or new cases in the prior decade. So incidence has increased 2.8-fold since 1996 survey, and indeed the sex ratio, females to males, is now at a level of about 3.1 in that incidence cohort. So I think overall what's very interesting from a clinical standpoint is that we're seeing an increase in cases more in women and more in younger women. So obviously this is an issue of why this is happening. And it leaves us with this million-dollar question: why is incidence going up? So we look at MS incidence, it's contributed to by a whole range of different factors. So we've alluded a little bit to the genetic component. So it's unlikely, however, that in a 20-year period, and as I've mentioned, this is a fairly homogeneous population in terms of migration, that genetics alone is likely to be contributing to this sudden hike or rise in incidence that we've seen. We've now, I think, all come to the conclusion that MS is not just a genetic disorder, it's probably an epigenetic disorder. So we've got these environmental factors which have been researched and identified as having, there's a number of them now and it's ever increasing, of factors that can be contributing to MS and probably have some sort of epigenetic relationship happening that can be impacting on MS. And we've also had a shift in our clinical management strategies, which I think someone alluded to before, that we're changing our diagnostic criteria to make it easier to report new cases. We have a greater access to MRI machines, and the awareness of multiple sclerosis in the general community, in the GP community, and in the neurological community is ever increasing. So the likelihood of detecting symptoms early and be reporting to their doctor have definitely increased. I'd like to sort of focus initially my next discussion about talking about some of these environmental factors, and it's just going to be a bit of a cook's tour of some of these factors, and I think some of the latter speakers will go into perhaps some of these other potential modulators in later talks. So let's look a bit about vitamin D initially. been a lot of attention about vitamin D, given the historical discussion about latitude effect and the exposure to sunlight. So we know that latitude is correlated to UV radiation, its duration and intensity, the amount of time that you are exposed to sunlight, and the UVB is the major source of vitamin D in most populations. So you can derive it from diet, but usually it's sunlight that is a major contributing factor to serum vitamin D levels. So we've seen from a range of observational studies with that latitudinal gradient there's an increased risk of developing MS the less sunlight you're exposed to, and we know that lower sunlight exposure does correlate to lower vitamin D status. And all this lovely summary is taken from Robin Lucas's paper in 2015, and she's had a lot to do with epidemiology of vitamin D and MS. We've also seen that if we supplement people with vitamin D, it can impact on their disease status as well. Again, suggesting that it's not only related to the incidence in developing the disease, but in terms of the actual progression and severity of the disease as well. But not to disregard the other components of sunlight. There's been some other work looking at the impact of UV exposure, not just vitamin D, but UV exposure, and has been shown that UV can impact on T-cell regulation and also the immune response. So maybe it's not just vitamin D, but other components of sunlight that we need to be addressing as well. There's now quite an extensive study running in Australia, as in other global countries. In Australia, it's the PREVANT study, which is looking at supplementing or giving CIS patients vitamin D and looking at the impact of second demyelinating event to see if there is in fact a protective effect of vitamin D once you've developed MS. And those studies are still ongoing. So smoking. Smoking's been blamed for everything in the modern world, I think every disease, but we do see, if you combine the data from a whole variety of studies now, we can see that the overall sort of, I think, normalised, if you like, risk factor of smoking is a 1.5 risk factor of developing MS. So smoking, again, potentially having some sort of epigenetic impact that could lead to MS. Hygiene hypothesis is a newer player, I think, to the game. One of the underlying premises of the hygiene hypothesis would indicate that an environment in which you have a rich kind of microfloral exposure, particularly in children, primes your immune system for an appropriate Th1 response. Now, as we go into a more Western lifestyle in a lot of countries and we're developing a more of a hygienic or sterile environment, it's more likely that we are developing more pathological phenotypes in terms of our immune response. So that's the underlying premise of the hygiene hypothesis. And again, it's quite interesting if we look at infectious diseases versus autoimmune diseases and what's been happening. So if we look at infectious diseases from 1950 up to 2000, a lot of these, and it's probably due to immunisation in many cases, but however, infectious diseases are on the decline, while autoimmune diseases, including MS and Crohn's disease and a range of other disorders, are on the increase. So whether that's a direct relationship or that's something to heed as well. The exception to this rule in terms of infectious agents is EBV. So we know that if you in fact have a low or a seronegative risk, you have a lower risk rate of developing MS if you're seronegative for EBV as opposed to those that are seropositive. So again, this is kind of the exception to the rule, and there's a lot of interest now in terms of B-cell interaction and how clearance of viruses and EBV antibodies are related to MS. Microbiota, another newer buzzword, seems our gut flora responsible for every disease and wellness state that we can imagine now, but gut microbiota is something that's very interesting, and because I come from a background of researching Crohn's disease and IBD, very interested in that gut-brain interaction. This is a study which, bless the Japanese of doing this, that they looked at a longitudinal study in 40 healthy controls and 20 MS patients, looking at longitudinal fecal samples and then analysing the whole microflora over time. And basically what they were seeing is that there was a dysbiotic MS kind of microflora happening. And I've just red lines around the Clostridium species in particular seem to be sort of discordant in numbers in MS patients compared to healthy people. So again, whether changes in our gut microflora are impacting on their ability to have a different or altered immunoregulation which could impact on MS. How could this be happening? Well, unfortunately, this is the trend a lot of people are taking in a lot of developing countries, that we're now seeing higher incidence of MS are heading towards this Western-style diet. And I think this George Jelinek is obviously a huge proponent of this. We're now looking at people having much higher salt intake, saturated fats, more red meat, more alcohol, more sedentary, and so we none of us want to go down this road and ending up like this, but unfortunately Western lifestyle and Western diet is now far-reaching and maybe contributing to MS. Now the thing is how and why. One could be body size. I thought it's interesting to look at these two studies that were done by Mungo. One she did in 2009, and this was looking at two large American cohorts. It was a retrospective study in which overall she had about close to 240,000 nurses, and they were asked to recall their body size at different ages. And then she looked at following those individuals up and found 593 cases of MS over a 40-year follow-up, and was able to show that the body mass index estimates in people at age 18 had a higher risk, between 1.4 of a BMI estimate between 25 and 27 of developing MS, and a relative risk of 2.25 if their BMI was above 30 or estimated to be above 30. So a higher BMI in early adulthood, in this case, seemed to be relating to an increased risk of developing MS when they were older. She then went on to do a prospective study in Denmark, and this was utilising a school registry of nearly 304,000 individuals, in which she identified 774 that went on to develop MS. Clearly the ratio here, the prevalence is much higher in Denmark than it was in the US. She was able to show as well that in girls, the hazard ratio associated with one increase in BMI between the ages of 7 and 13 resulted in a 1.2 hazard ratio for developing MS. And indeed those that were in the 95th percentile of BMI within this age group as well, in girls had an increased hazards ratio at 1.8 of developing MS, and in boys 1.5. So taken together, it's possible that health status, BMI and obesity in adolescence or in young adulthood could be linked to an increased incidence risk of developing MS. So what could be happening with adipose tissue? Well, we know that adipose tissue is pro-inflammatory. Basically, adipose tissue reduces adiponectin levels, which can lead to a pro-inflammatory cascade happening, and this can have detrimental effects on neuronal tissue. So this needs to be investigated further, but it's possible one avenue of interest could be, does adipose tissue in this age group predispose people to a pro-inflammatory cascade, which can lead to the development of MS? As someone mentioned before, yes, our diagnostic criteria has changed. So we've gone historically from the POSA criteria, which was based on clinical relapses to lead to a clinically definite MS being characterised. But now we've moved in the 2000s to McDonald criteria. So this enables us to diagnose people at a much earlier level. It does require access to MRI, but it means it may be contributing to more cases and therefore an increased incidence. And I think what's interesting, if you look, and again this is from the recent MS Atlas, to the, just this last graph at the end here, which is looking at the number of MRI, basically the ratio of MRI machines in developing countries per population, we can see that within this period of time there's been a dramatic increase in availability of MRI machines in developing countries. So the ability for physicians to diagnose MS on the basis of these new criteria has increased, and indeed this could be contributing to increased incidence of MS. So how do all these factors that I've just given you the cook's-through on, really, how can we attribute this or some of these factors to what we're seeing locally in Newcastle? I haven't looked at these directly epidemiologically, but I've taken information from the New South Wales Population Health Survey, which is a branch of ABS as well, and looking at things like sun exposure. Now, we know in the last 30 years that our awareness of sun exposure has increased. It was 1981 when the Cancer Council launched its Slip Slop Slap campaign, which was very effective in the media. And as a consequence now, also in the cosmetic industry, we've got UVA, UVB blockers in our moisturisers, in our makeup, in a whole range of products. And everyone's encouraged in schools to wear hats to cover up in the sun. So the AusD study has also shown that these modifiable factors that change your sun exposure have a direct effect on vitamin D levels. So it could well be, in the Newcastle scenario, part of these modifiable factors in terms of our lack of going out in the sun quite as much could have been increasing our MS risks. Smoking rates is another one. So what's happened with smoking rates? If anything, smoking rates have actually gone down. So it's unlikely that an increased smoking can be attributed to increased incidence. Since 1997, adult smoking rates, these are daily smokers, has actually declined from 19% of the population in New South Wales to nearly 12%. And with this reduction has been seen in both men and women and in urban and rural areas. So I don't think we can attribute smoking as a potential risk of increasing our incidence rates. We talked about diagnostic criteria. What we actually did in our 2011 criteria to make it comparable to the 1996 and the previous work that was done is we diagnosed people on the basis of the McDonald criteria, but also on the POSA criteria, and they fulfilled both those criteria. So we don't think that it was the utilisation of the McDonald criteria that would have contributed to the increased numbers of cases that we saw, because the patients also complied clinically by POSA criteria as well. Not to say that globally this could be having an impact, particularly in newer developing countries. BMI and obesity, I think, is a really interesting area in the sense that from 1997 to 2010, there's been a rise in the proportion of adults who are considered to be overweight and obese in New South Wales from 42% up to 54%. And these trends are seen in both men and women. So the alarming thing is this is not just in adults, but in children. If we look at body mass index, 1995 to 2007, we can see that there's been a trend for an increase in overweight children and also in the obese level as well. So this is matched with, if we look at the activities of these kids and what they're actually doing with their free time, if you look at hours in a day, we're seeing a much more sedentary population of children, and I think any of those of you with children or around children would agree with this. This is just the numbers to really support it. So 2 hours or less a day are spent probably in organised sporting activities or playing outside, whereas more than 20 hours a day are spent watching television or playing video games. So we're developing a larger population of children that are more sedentary in their lifestyle. So if we look at the obesity rates in boys, 5 to 17 years, it actually rose from 5% in 1995, and that doubled between 2007 to 2008. And in girls, the proportion of girls who were overweight has definitely increased. And this, interesting again, this sort of age range of that pubescent sort of early adolescent stages in girls was seen in older girls, and it rose from 12% up to 20% in 2007 to 2008. So again, that same, I guess, sort of fits in with what Munga was seeing previously, that we could be looking at a more at-risk young female population, potentially contributed to by these changes in lifestyle and changes in obesity. So as I mentioned, this impact of increase of incidence and prevalence isn't just restricted to Newcastle nor Australia. We're seeing this globally, and it's being seen in a number of countries. So I'd like to sort of focus on 3 case studies that have been reported at the recent ECTRIMS meeting in Asia, particularly in North Japan, in the Middle East and in Latin America, and to see what's happening in those different countries as well. So if we look at Asia, you know, as we all know in this room, that NMO is the predominant type of condition seen in relation to MS, and indeed the NMO to MS ratio historically was always very high. We're now seeing an ever increasing number of MS cases. So if we're looking at up to the 2015 data here, they've actually reported in northern Japan 13,000 MS cases as opposed to 5,000 NMO cases. So definitely the ratio of NMO to MS is reducing as we're seeing more and more MS cases being diagnosed in Japan. Looking at the Tokachi province, which has had the most consistent registry of Japanese MS cases, if we look at the population itself, it's actually probably between 1960 and 2020. It's actually stabilised. It was a rapid rise between the 1920s and the 1960s, 1990s, and it's kind of stabilised. So we're looking at a fairly consistent number of people in the region. But the prevalence rates of MS in northern Japan in both sexes has increased, and it's doubled from 2001 to 2011. A lot of thought from the presenter, Dr Hagachi, who presented this at ECTRIMS this year, was indicating that he feels it's contributing to by a Western lifestyle and a Western diet. That's yet to be ascertained with any numbers. That's sort of just his own opinion. Looking at Middle East and Iran, so we've got 2 maps here, the red showing cases of more than 30 reported MS cases in Iran, each of these borders showing different provinces. Between 2006 and 2011, there's a clear increase in the numbers of cases seen in different provinces in Iran. Now, what's interesting is they've done some studies correlating between their prevalence rates with urbanisation in those areas, because the country has gone through an increase in westernisation, increase in quality of life for a lot of people in the region. So they're comparing and seeing a significant association between the level of urbanisation and industrialisation and in male smoking between prevalence rates of MS and these various variables. So again, potentially this westernisation lifestyle could be contributing. I think the key thing to note, though, for Iran is a question around the reliability of the registries that are utilised. I mean, obviously, it's been mentioned, the denominator in your prevalence rates is critical. So the census rates that are being derived could be questionable in terms of the accuracy, and also the access of these countries to MRIs has dramatically increased as well. So it could be just contributing to that increased number of cases. Finally, Latin America. This is the most recent study I could find from 2013, and if you can see the map on the right, even though we are transversing quite a wide latitudinal range, there's really no clear delineation in terms of MS prevalence rates. The reason being here, I think, again, it comes down to quality of registries for looking at MS cases. And this is a compilation of data derived from registries developed in 1991, which would have been those in Mexico, to the more recent 2011. So I think this is a very much watch this space in terms of Latin America to see what happens over time once their registries and diagnostic criteria has improved, how this is going to change in trend. So basically, as an overview to the work I've presented today, we can see that there's a prevalence of MS has continued to rise on a global scale. It may be due to an improvement in therapeutic strategies and the reduced mortality rate that we see in our MS cases. This is being seen in countries that historically had a lower prevalence rate outside of Europe and North America, and this could be contributed to by an increase in MS incidence. The latitude gradients are becoming less obvious because of these conflicting factors. It could be impacted on by a range of environmental and clinical factors, And while environmental and social factors, quality of healthcare could be contributing to MS prevalence and incidence in developing countries, I don't know that that's fully the case in Australia. And potentially modifiable risk factors such as our sunlight exposure, our diet, changes in lifestyle could be impacting on autoimmune conditions and therefore resulting in the dramatic increase in MS we see in Newcastle. Thank you.
Thank you so much, Karen. That was a brilliant talk. Thank you so much. Brilliant. Would anyone like one quick question? Any other questions at morning tea? Dr. Gordon.
Is obesity a marker of the gut flora being disorganised? Because there is some data to suggest that in mice they become obese with repeated exposure to antibiotics. Is there any data on antibiotics in obesity?
No, not that I've seen, not that I'm aware of. Yeah, and not definitely related in MS. We're starting to collect more and more at a clinic setting, looking at relapse rates in obese patients to see if the progression of the disease is more impacted, but no one's, I think, looked at that association with microflora obesity and disease. So that's a good study.
Thank you very much, Karen. That's brilliant.